Hello everyone, I am Yi-Chiao from Meta. Today I would like to introduce our work, AudioDec, an open source streaming high-fidelity neural audio codec. An audio codec is a technique to compress audio into compact cores and then to construct the audio based on the cores. A typical codec includes three modules. First, an encoder module encodes high temporal resolution audio waveform into low temporal resolution representations. Secondly, a quantizer quantizes the representation into discrete cores. Last, a decoder reconstructs the audio waveform based on the discrete cores. A practical audio codec for two-way human communication includes three factors. First, the compression bitrate is usually lower than 64 kilobits per second. Secondly, the delay should be shorter than 130 milliseconds. Last, the sampling rate of the audio is usually higher than 24 kHz for high-fidelity speech coding. In this work, we propose a stringable audio codec named AudioDec, which encodes 48 kHz audio with only 12.8 kilobits per second and run real-time on GPU with 6 millisecond latency and CPU with 10 millisecond latency for 12.5 millisecond buffers. The main contribution of this work are the proposed efficient chain paradigm, modularized architecture, and low latency implementation. We find that the metric loss, such as mere spectral loss, already covers most high-level information for speech coding. And the adversary losses focus on only the high-frequency details, which is more related to the decoder only. Therefore, we propose an efficient chain paradigm to first train all modules with only metric losses in the stage 1, and then only updating the decoder using both metric and adversary losses in the stage 2. The proposed chain paradigm greatly reduces the chain time. Furthermore, replaceable encoder and decoder are essential for different scenarios, such as denoising encoder, and binaural decoder. And we found that the symmetric encoder and decoder are essential for chain stability, but a powerful decoder is required to achieve high-fidelity speech generation. Therefore, we propose the modularized architecture to fix the quantizer and the codebook while training a new encoder for new scenario or a powerful decoder for high-fidelity speech generation. For the low latency implementation, we adopt one-side padding to achieve causal convolution for stringable. For real-time generation, we adopt non-autoregressive architecture for parallel inference. We replace the multi-reset field MRF with ad hoc kernel size of the hi-fi gain generator with the group convolution of the single kernel size, which is hardware friendly for parallel computations. In our experiment, we adopt a BCTK subset, Valentini corpus for experiment. The sample rate is 48 kHz. The corpus includes gender-balanced 84 chain speaker and 2 testing speakers. Each speaker has around 400 utterance. 7 systems were evaluated. The baseline sound stream codec, the symmetric audio deck with and without fixing the encoder in the chain stage 2, the symmetric audio deck with a hi-fi gain-like decoder, the proposed audio deck with the vocoder-based decoder, which first train a symmetric audio deck and then train a hi-fi gain vocoder using the cores extracted by the trained encoder. Version 0 adapts the original hi-fi gain vocoder with the MRF module of kernel size 3, 7, and 11. Version 1 replaces the MRF module with the group convolution module of kernel size 11. Version 2 replaces the MIF module with the group convolution module of kernel side 3. Both objective and subjective evaluation were conducted. According to a result, we can find that the proposed vocoder-based approach outperforms ours. The symmetric structure actually suffered quality degradation because of the chain instability. Fixing the encoder in the chain stage 2 still maintains the quality. And the group convolution module achieves comparable performance as the MIF module. We adopt segmental generation to analyze the latency, which encode and decode the audio buffer by buffer. According to the result, we can find that the group convolution module greatly reduces the latency. And the proposed AudioDec can run on both GPU and CPU with a 25 millisecond buffer size. Thanks for your attention. Please check our GitHub repo and demo page for more details.